आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hi friends, the question is, how is ammonia prepared on a large scale? Name the process and mention the optimum conditions for the production of ammonia by this process. This is the first question. And in second part, assign reasons for the following. That is H2S, hydrogen sulfide is more acidic than water, and ammonia is more basic than phosphine, and sulfur has a greater tendency of catenation than oxygen. Okay. So let us discuss the answer. So in first one, how is ammonia prepared on large scale? So the ammonia can be produced on a large scale in industries through Haber's process. Okay, Haber's process. So in Haber's process, the nitrogen or reacted with hydrogen in presence of iron as a catalyst, the formation of ammonia as a product. Okay, there will be formation of ammonia, and here I balance the equation. So the optimum conditions, the conditions that should applied for the formation of ammonia through Haber's process is that should be high pressure. Okay, high pressure should applied around 200 atmospheric pressure. Okay, around 200 atmospheric pressure, and there should be temperature that should be around 400 to 450 degrees centigrade or around 700 Kelvin. Okay, and there will be use of iron oxide, that is Fe2O3, and small amount of and small amount of potassium oxide K2O and aluminum oxide. Okay, as a promoter. So promoters are used in Haber's process along with catalyst. Promoters are nothing but they are added with catalyst, okay, to improve or to increase the reaction process, to increase the selectivity of the product. Okay, so promoters are added to the catalyst to increase or to improve the performance of this chemical reaction along with the catalyst. Okay, so that is called promoters. Okay, so promoters here are iron oxide along with a small amount of potassium oxide and aluminum oxide. Okay, so these are promoters. Potassium oxide and aluminum oxide are promoters along used with the iron as a catalyst. Okay, so this is about the Haber's process, which used as a large scale preparation. Okay, in large scale industry, Haber's process are used to produce ammonia. Okay, so let us discuss the second part, that is assign reasons for the following. So first one is the hydrogen sulfide is more acidic than water. It is due to because sulfur H. So the second one, because the sulfur H bond, the bond between the sulfur and hydrogen bond in H2S is weaker. Okay, it is weaker than OH, oxygen hydrogen bond in water. Okay, bond in water. So H2S, as a result, H2S release proton. Okay, it will release the proton more easily, quickly or more easily than water. Okay, so it is acidic. It releases the more proton, so it is acidic. It is more acidic, and we know that water have a character of amphoteric. That is, it can either accept the proton or it can release the proton. Okay, so so the reason is that due to the weaker bond between the sulfur and hydrogen, it will easily release more proton, that will lead to the more acidic in nature of H2S than water, and water being the having the characteristic of amphoteric, that is, it can either accept or release a proton. Okay, so this is the reason. So proton, due to the more release of proton, it is more acidic. Okay, H2S is more acidic, therefore H2S is more acidic than water. Okay, and then the let us discuss the second one. So that's is ammonia is more basic than phosphine. So ammonia is more basic than phosphine. So here The reason why ammonia is more basic is that ammonia in nitrogen in ammonia basic than phosphine. Okay, so the reason behind is, so the nitrogen is smaller, okay, smaller in size than phosphorus. Okay, so the lone pair of electrons in nitrogen or can easily donated. So lone pairs on nitrogen can easily donated. Okay, but in phosphorus it is little bigger than nitrogen. So due to its bigger size, phosphorus is bigger in size, so the lone pairs does not ready to donate. Okay, does not ready to donate its lone pair of electron. Okay, so that due to the lone pair of electrons on nitrogen can easily donate, so because donating the electrons is called will have the basic nature. So it is as it donates its lone pair of electrons, it is more basic. Okay, more basicity. There will be more basicity in ammonia than phosphine because it has less basic. Okay, it is less basic, and it cannot or it does not ready to donate it lone pair of electrons as due to the bigger size of the phosphorus than compared to that of nitrogen. Okay, so this is the reason why ammonia is more basic than phosphine. Okay, so this is the reason. And finally sulfur has a greater tendency of catenation than oxygen. Okay, so sulfur has a greater tendency of catenation. So sulfur has greater tendency for catenation than oxygen. So that is the final one. So in this case, actually sulfur bond is stronger. Okay, bond is stronger when compared to that of than oxygen bond. Okay, so actually before going into the reason, we have to know what is catenation. So catenation is nothing but the self-linking of atoms. Okay, so catenation is nothing but self-linking of atoms of the element into chain or ring. Okay, into chains or rings. So that is said to be catenation. So sulfur can, due to the stronger bonding between the sulfur and sulfur, the sulfur can undergo easily catenation than the oxygen. Okay, so due to this reason, the sulfur can easily undergo catenation. For example, SC8 is a naturally occurring molecule which can when heated, it can undergo some transformations, like it can undergo breaking of bonds between themselves, breaking bonds within and form ring to chain. Okay, ring to chain compound. Okay, in this SC8. So this is the reason why sulfur has a greater tendency for catenation than oxygen, because it has a stronger bond. Okay, so that makes them to have a catenation property. Okay, so this is the final answer for the given question, and this is second one and this is first one. Okay, sorry, this is first one. Okay, so in the second part it is first question. Okay, so these are the given reason and these are the answers. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।